Hello. Today we're going to talk about oxidation and reduction and then balancing oxidation and reduction reactions. So, first of all, oxidation is when an element is losing electrons. Reduction is when that element is gaining electrons. So, Leo is loses electrons oxidized. Ger gains electrons reduced. Leo the lion says Ger is one way to remember which is oxidized and which is reduced. Okay, so oxidation, losing electrons. And you can't, these have to be together. They go hand in hand. When something's losing electrons, something else has to be gaining the electrons. So these reactions can be used to produce electricity then. Now we need to determine whether a reaction is oxidation or reduction. So then we will have to look at what the oxidation numbers are as of the elements as reactants and then what they are as products to see if they've changed. And if the oxidation number changes, then we know that oxidation or reaction and reduction is happening. All right, so first of all, you have to know how to figure out the oxidation number of elements. That would be prior knowledge. If you don't know how to calculate that, you need to, or figure that out, you need to look back at calculating oxidation numbers. For instance, every naturally occurring element, its oxidation number is 0. So hydrogen in H2 is 0. And then oxygen is also naturally occurring there in O2, so it is 0. Then we look at what happens to the hydrogen in the reaction. Hydrogen here is with a nonmetal, so it is +1. If hydrogen's with a metal, it's -1. And then oxygen's oxidation number in compounds is almost always -2, unless it's a peroxide or if it's with fluorine. So the oxygen is going from 0 to -2, the oxygen is. So that means the oxygen's being reduced. It's getting more negative. It's gaining electrons. Whereas the hydrogen in this reaction is going from 0 to +1. So that means it lost an electron. So it's oxidized. Okay, next slide. The substance that's removing the electrons is called the oxidizing agent. The substance that's giving up the electrons to another substance is called the reducing agent. So in this little example, hydrogen is being oxidized so that the reactant that H2, that hydrogen was in, it's the reducing agent. And oxygen is being reduced, so the reactant that oxygen is the oxidizing agent. So the reducing agent and the oxidizing agent will be reactants, right? So again, the hydrogen was being oxidized, so H2 is the reducing agent. Oxygen is being reduced, so the O2 is the reducing agent. So we want to look at balancing oxidation reduction reactions. Shortcut for them is called redox reactions. And we're going to do this using what's called the half reaction method. If you follow this through step by step, then you should have a perfectly balanced equation at the end, including the charges. But you must go in this order. So first of all, if you're given the reaction as a whole, you need to divide it into 2 half reactions. Then we just go through these steps for each reaction. Balance atoms other than oxygen and hydrogen, then balance oxygen by adding water, and hydrogen by adding H+, and the charge by adding electrons. So this is like a little bookkeeping method. When we say we're adding water, these reactions are happening in water. So we're not really adding something that's not already there. We're just keeping track of things. And the same thing with H+. If it's in acidic solution, there's already H+ there. Again, we're just keeping track. And then when we put them back together, the electrons will cancel out and it would be balanced. So if you have this happening in acidic solution, you should end up with H plus on one side. If it's in basic solution, then we'll have to do an additional 2 steps. So let's go through the example. It's much easier when you see it. Okay, so first of all, this is the reaction we want to balance. Balance the following redox reaction. We have Cr2O7 minus 2 plus I minus going to Cr plus 3 and I2. And it tells us it's in acidic solution. So that's important to note. So first of all, to separate the reactions, we can see that the Cr on one side has to end up as Cr on the other side. So that's one of the half reactions, the Cr2O7 minus 2 going to Cr plus 3, and then the other one is the I minus going to I2. Okay, so step number 1, after we separate them into the 2 half reactions, balance atoms other than oxygen and hydrogen. This is crucial. I put a star by it because people often forget this step and then everything else will be incorrect at the end. So there's 2 CRs here. So we need to put a 2 in front of the Cr plus 2, or plus 3, sorry. Okay, so that's balancing the CRs. And then on the other one, we have to put a 2 in front of the I minus. So now there's 2 iodines on both sides. You have to balance atoms other than oxygen or hydrogen first. All right, next step, balance oxygens by adding water. So I look here and I see there's 7 oxygens on this side. There were no oxygens on the chromium plus 2 side, so I'm adding 7 waters to get 7 oxygens. All right, that's just do that first. I look at the other one, there's no oxygen, so I don't worry about it. Okay, well, now that I've added 7 waters, I've also added hydrogen, so 2 times 7. I've added 14 hydrogens also. So the next step is balance hydrogens by adding H plus. So I have 14 hydrogens on this side, so I'm going to add 14 H pluses to the other side. At this point, all the atoms should be balanced, and you should double check that. So 14 H's on both sides, 2 chromiums on both sides, 7 oxygens on both sides. The other one, all I had to do was balance the atoms, so there's 2 I's on both sides. All right, next step, balance the charge by adding electrons. So we can only add electrons. We can't take away anything. We can't add positive charges or whatever. So first, add up the total charge. There's 14 pluses in here, plus a minus 2. That means that the total charge on the reactant side is plus 12. On the product side, there's 2 times 3 plus 6 total. So I can only make it less positive by adding electrons. So if I add 6 electrons to this side, now that's going to make that plus 6 on that side as well. Okay, so adding electrons will balance my charge, and I'm adding 6 to this side. For this one, it's minus 2 on this side and 0 on this side. So I add 2 electrons to this side, and now it will be balanced. And so the one half reaction that has electrons on the reactant side, that means that's the reduction reaction. Electrons gains, electrons reduced. So this one's the reduction reaction, and the one that has electrons on the product side, that means that that's the oxidation reaction. Electrons are being given up, or it's losing electrons. When I want to put the 2 half reactions back together, the electrons have to cancel out. So in the one I just was doing, I had 2 electrons only in this one and 6 electrons going into this one. So I have to balance the electrons by multiplying this reaction by 3, which will multiply all the way through. So 3 times 2 gives 6I minus, 3I2, and then 6 electrons. Then I will have 6 electrons on the reactant side of the one and 6 electrons on the product side of the other, and those cancel. That's the only thing that cancels in these two. Sometimes when you go to put them back together, you might have water on both sides, or both of them have water on the same side, and you add together the waters, and the H pluses too. But in this particular one, there was no water or H plus in this one. So the only thing that cancels out are the 6 electrons. And now I put them together. So I had 6 I minuses from this one on the reactant side, 14 H pluses, and a Cr 207 minus 2 on the reactant side. That takes care of the reactants from both. And then the products, I had 3 I2s in this one, and then I had 2 Cr plus 3s and 7 waters in that one. And that is a balanced equation now. Okay, but one more time, when you put them together, if you end up with waters on both or H pluses on both, you have to make sure that you add those if they're on the same side, or cancel them out if one's on one side and one's on the other side. Okay, so that's in acidic solution, you should end up with H plus on one side. Okay, so then if we were going to do this, just kind of going through it a little more quickly without writing out every single step. I kind of do it all at once. So first of all, I have the MnO4 minus going to Mn plus 2 as my 1/2 reaction. And I'm just going to do the other one underneath it. I have HCOOH going to CO2. Okay, so balanced atoms other than oxygen. In the first one, I have just Mn, one on each side, so that part's done. In the second one, I have 1 carbon on each side, and I'm right now ignoring the hydrogens and the oxygens. So my carbons are balanced, my manganese is balanced. So next thing, balance oxygens by adding water. So I would need to add 4 waters to this side on this one to get 4 oxygens. And here I have 2 oxygens and 2 oxygens, so that's already balanced. Next, balance hydrogens with H plus. I have 8 hydrogens on that side, so I need to add 8 H pluses to this side. And on this one, I have 2 hydrogens, and I'm going to add 2 H pluses to this side. So at this point, all of my atoms are balanced. Now I look at charge. I have 8 pluses and a minus, so I have an overall charge, I'm going to change color, of plus 7 over here. Over here, I have plus 2 and 0, so I have plus 2. So I need to make those equal. So if I add 5 electrons to this side, that will now make that plus 2 for the whole side, and that's balanced. And then on this one, I have plus 2 on this side and 0 on this side. So I'm going to add 2 electrons to this side to make that 0 as well. In order to put them back together, my electrons have to cancel. So I'm going to multiply this one by 5 to go up to 10 electrons, and this one by 2 to go up to 10 electrons. Okay, so the common multiple is 10 for these. So now I'm going to rewrite that right underneath it. I'm going to do it in blue. I like to rewrite it when it's both of them I'm getting multiplied by numbers before I put them together. Okay, so multiplying that one by, go all the way down here. Multiplying that one by 2 would have given me 16 H pluses for the top one, plus 2 MnO4 minus goes to 2 Mn plus 2 plus 8 waters. And then I'll do the other one in a different color. Multiplying that one by 5, I'll get 5 HCOOH goes to 5 CO2, plus 10 H plus 10 electrons. So now I can look to see what they have in common. They have, and I didn't put the 10 electrons on this one. So there was 10 electrons here from this one. Okay, so now I have 10 electrons on the first one's reactant side. That means it's the reduction reaction. The electrons are on the reactant side. And those are going to cancel with the 10 in the other reaction, which is my oxidation one, where they're a product. So those cancel. And then I have 16 H pluses on this side and 10 H pluses. So I can subtract out 10 H pluses from both and get 6 H pluses left over. And then I can just put those together and I will have 6 H plus on that reactant side plus 2 MnO4 minus, if you want to even draw a line to show you're adding those together. And then there's 5 HCOOHs on that reactant. And then on the product side, I have 2 Mn plus 2 plus 8 waters plus 5 CO2s. And just a quick check, 5 carbons, 10 hydrogens there plus 6 more, 16 hydrogens plus 16 hydrogens. And then I have 8 plus 10, 18 oxygens there. I have 8 there and 5 times 2, 10 there. Yep, everything's balanced. Okay, so when it's an acidic solution, you're finished. If it's in basic solution, however, there's an extra step, really 2 extra steps. If it's in basic solution, you have to add OH minus to both sides for your next step. So you'd still go all the way through like we just did, but now when you have H plus on one side, you'll have to add that many OH minuses to both sides. And then the H plus and the OH minus will make water. And then you have to simplify if you then have waters on both sides or on the same side or whatever. So we'll go through one like that. Okay. Here's the skeleton equation, and it tells us it's in basic, right? So again, we separate them into 2 halves. So I have MnO4 minus going to MnO2, and I have I minus going to, that's an I, going to IO3 minus. All right, so again, just going through the steps, I have my atoms are already balanced on this one, the MNs, and I ignore the oxygens for a minute, and my I's are already balanced. So then I balance oxygens with water. I've got 4 oxygens on that side, only 2 on this side, so I need to add 2 waters. On this one, I need to add 3 waters on this side to get 3 oxygens, and now those are balanced. But now I look at my hydrogens. I have 4 hydrogens on this side, so I need to add 4 H pluses to this side. And over here, I've got 6 hydrogens on that side, so I need to add 6 H pluses to this side. Okay, so at this point, all of my atoms are balanced. Now I need to look at charge. Over here, I have 4 pluses and a minus, so I have a +3 charge overall. And this side, I have 0. So I'm going to have to add 3 electrons to this side to make that 0. And down here, I have a -1 on this side total, and I have a -1 here, but 6 pluses here, so I have a +5 on this side. So I need to add, or sorry, a +6 on this side. No, it's +5 on this side, sorry. So now I need to add 6 electrons to make this be a total of -1 on this side. Okay, so I'm adding 6 electrons to this side. So basically then those cancel, and I'll have -1 here and a -1 here, -1 on both sides. All right, and now I have to make the electrons cancel. So there's 3 electrons in the first one, 6 electrons in the second reaction. So I'm going to have to multiply this reaction by 2 to get my electrons to cancel. And so rewriting that, let's write it in black. I'm going to multiply this whole reaction by 2. So there'll be 8 H pluses plus 2 MnO4 minuses plus 6 electrons on that reactant side goes to 2 MnO2 plus 4 H2Os on that side. All right, and now I'm going to erase this just so that I can add these together. Now I'm going to add these together, and my 6 electrons are going to cancel. One was on the reactant side, the other was on the product side. I have 4 waters in this reaction and 3 waters in this, so I can cancel out 3 and make that a 1. And I have 6 H pluses in this one and 8 H pluses, so I can cancel out those 6 and take away 6 here and make that 2 H pluses. Okay, so rewriting it, I'll have 2 H pluses plus 2 MnO4 minuses plus I minus is all that's left on the bottom one, goes to 2 MnO2 plus 1 H2O plus an IO3 minus. And looking carefully, I got my 2 H pluses. And do I have everything? Always double check, make sure everything balances. 1 I on both sides, 2 H's on both sides, 4, 8, 4 plus 4, yep, 8 oxygens on both sides. So it's balanced. But because it's in basic, now this is where there's the extra step. I ended up with 2 H pluses on this one. So that means to both sides, because it's already balanced. So whatever I do to one side, I have to do the other. To both sides, I'm now going to add 2 OH minuses. On this side, H plus and OH minus make 2 waters. On this side, it doesn't add in with anything. It's just the 2 OH minuses, right? So now I have 2 waters on this side. I had 1 water on this side, so I can subtract out 1 water from both sides. And my final reaction will be, let's see, let's write this one back in blue. So my final reaction will be, there's 1 water plus 2 MnO4 minuses plus an I minus goes to 2 MnO2 plus an IO3 minus plus 2 OH minuses. And that's completely balanced, and it has the OH minus on both sides. I mean, the OH minus just on the one side because it's basic. And so there are a few questions from past Olympiads that you can try, and then I gave you the answer. So for the one, what's the coefficient for zinc when it's balanced with the smallest whole number coefficients? So you have that reaction there. You have to go through those steps. You would separate into the 2 half reactions. So you have zinc going to zinc plus 2, and then you'll have the hydrogen plus the NO3 minus going to N2O plus H2O. Those are the 2 skeleton equations. And then you need to go through all the steps, balance those, and see what your ratio or what the coefficient for zinc is. Okay, so just going through those exact steps like we just did, and you should come up with that you have a 4 for zinc. Another question from the Chemistry Olympiad local exam says, for the balanced equation, which statement is correct? Is Fe plus 2 undergoing oxidation? Okay, so Fe plus 2 on the reactant side becomes Fe plus 3. So it's getting more positive. So it is losing an electron. So yeah, Fe plus 2 is undergoing oxidation. That is true. Is Fe plus 2 the oxidizing agent? No, if it's being oxidized, it's the reducing agent. And then H plus is undergoing oxidation. Is that true? No, it's plus on the reactant side, and in water, it's still plus 1. So H plus is not undergoing oxidation, and it is not the oxidizing agent. So the correct answer is A. And then this one was from the 2017 local, and it's another one like the first one. You're going to have to separate to the two half reactions. So you'll have Cu going to Cu plus 2 for the one reaction, and you'll have H plus NO3 minus going to NO plus H2O for the other reaction. And again, you would just go through all the steps. And then that question asks, what's the ratio of coefficients from H plus to NO? So you have to get it all balanced. And then you should see that it's a 4-to-1 ratio. So I hope this helps you with balancing oxidation reduction reactions. Have a great day.